Applications of thermodynamics. Grace, Jane, and Tiffany.
The Earth's energy balance and the greenhouse effect. The Earth's energy balance describes how the incoming energy from the Sun is used and returned to space. If incoming energy and outgoing energy are in balance, the Earth's temperature remains constant. It is essential to know that the Earth's energy balance drives the weather and life on Earth, as it is determined by the balance of solar radiation coming in and the outgoing heat radiation. When energy from the sun or another source enters an object, the infrared radiation that comes out can be larger or smaller than the amount that enters. However, not all of the infrared radiation escapes immediately. Essentially, 100% of the Earth's energy comes from the sun. So to maintain a constant global average temperature, all of the sun's radiation that enters the Earth must eventually be sent back into space. This is achieved through Earth's energy balance. The greenhouse effect is a natural process that warms up the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space and the rest is absorbed by re-radiated greenhouse gases molecules. Just as the major gases such as oxygen and nitrogen are transparent in incoming light, they are also transparent to outgoing thermal infrared radiation. The sun emits light photons, which go straight through nitrogen and oxygen molecules, as well as water and carbon dioxide, which can be found in the air. Infrared photons then get absorbed by the water and carbon dioxide molecules, and this gives them energy. Water can act both as our best friend and our enemies when it comes to greenhouse gases. When greenhouse gases molecules absorb the thermal infrared energy, the temperature increases. Like coal from a fire that is warm but not glowing. Greenhouse gases then re-radiate, and an increased amount of thermal infrared energy in all directions. Heat radiated upward continues to encounter greenhouse gas molecules. Those molecules absorb the heat, their temperature then rises, and the amount of heat that they radiate increases as well. Instead of keeping the energy, the molecules re-radiate it. Some of this re-radiated infrared radiation goes back down and warms up the surface of the Earth. Because greenhouse gas molecules re-radiate the heat in all directions, some of it spreads downwards and ultimately comes back in contact with the Earth's surface, where it is absorbed. The temperature of the surface becomes warmer than what it would be if it was heated directly by solar heating. This supplemental heating of the Earth's surface by the atmosphere is a natural greenhouse effect.